It is also called as capacity limited metabolism or mixed order kinetics. Why? Because at high concentration it gets saturated. Here you can say when enzyme react with substrate, it forms enzyme substrate complex and the product is formed. When the enzyme again go back to react with another substrate, it forms another molecule of the product. Next is Michaelis-Menten equation. Michaelis-Menten equation, or you can say non-linear pharmacokinetic, can be best described by Michaelis-Menten equation, and the equation is minus dC by dt is equal to V max C divided by Km plus C, where minus means decline. So minus dC by dt means rate of decline of drug concentration with time. Vmax means theoretical maximum rate of process. Km means Michaelis constant. Next is, these are the three situations which can be considered depending upon the values of Km and C. Now first situation is that when Km is equal to C. When Km is equal to C, under this equation you can say minus dC by dt is equal to V max C divided by C plus C. Here, if Km is equal to C, then the value of Km you can put instead of Km the value C. So equation will become Vmax divided by C divided by 2C, and C will be cancelled. Then the equation will reduce to minus dC by dt is equal to Vmax divided by 2. It means that the rate of process is equal to 1/2 of its maximum rate. Now this is the second equation when Km is greater than. When Km is greater than C, here Km is equivalent to Km. Then the equation reduces to minus dT by dC minus dC by dt is equal to V max C divided by Km. The above equation is identical to the one describes first order elimination of a drug where Kmax divided by Km is equal to Ke. Next is third condition, or you can say third situation, when Km is lesser than C. Here Km plus C is equivalent to C. Then the equation will become minus dC by dt is equal to Vmax, as the C and C got cancelled. So above equation is identical to one that describes a zero order process. You can say in first equation rate of process equal to 1/2. In second equation it describes first order elimination. In third equation it describes zero order process. Now these above are the three situations which can be considered depending upon value of Km and C. Next is a plot of Michaelis-Menten equation. In this, a graph is plotted between elimination rate, that is minus dC by dt, versus concentration C. You can see initially the rate increases linearity first order with concentration, then it becomes mixed order at higher concentration, then it reaches maximum, beyond which it proceeds at a constant rate. So this is all about the Michaelis-Menten equation. I hope so you will be able to define pharmacokinetics, linear pharmacokinetics, non-linear pharmacokinetics, difference between linear and non-linear pharmacokinetics, to detect non-linearity, what are the causes of non-linearity, then Michaelis-Menten equation, then the three situations considered depending upon the value of Km and C, and finally the plot of Michaelis-Menten equation.